Hi, Professor Hildebrandt here. I'm going to work some more calculations of probability from Chapter 5. This one is going to focus on our rules of addition. So our first example, we're going to start with the special rule of addition. And the important feature here is that our outcomes are mutually exclusive. This means if outcome A occurs, outcome B cannot occur, okay? Or if B occurs, A cannot. So to find the probability of A or B occurring, we add the probability of A occurring to the probability of B. Let me give you some real numbers and see if it makes a little more sense. So here's our example. We have a sample of 200 firms, and we have their income after taxes. And so we see we have three potential outcomes, A, B, and C. The first outcome is that the firm earns less than $1 million, and there are 102 firms in this category. The second outcome is that the firms earn between $1 million and $20 million, and there are 61 firms there. And then the last category is that we have firms, 37 of them, that earn income in excess of $20 million. So now we're going to look at several questions of probability with this data. So first, I'm just going to use what's actually a very basic probability approach called the empirical approach. Let me write this word down here so you understand what I mean. So I'm going to use the empirical approach to find the probability that a firm that's randomly selected from our sample would be one of those that earns under $1 million, which was outcome A. And to do the empirical, you just take the number from the number that's possible, so there's 102 that earn less than $1 million, and you divide by the total, which was 200. So we do 102 divided by 200, and so we would say the probability of randomly selecting a firm that has outcome A, income less than 1 million, is equal to 0.51. Okay, and so that's how we would answer question A. Question B says, we'll find the probability that a randomly selected firm would have outcomes B or C. And so looking back at our data, B would mean they're in the 1 to 20 million, and C would mean that they're making 20 million or more. And this is where we use what's called the special rule of addition. And it's special because there's a general one that I'm going to go over next. So here we're going to use the special rule of addition, and I gave you the formula earlier. We just take the probability of B occurring, and we add that to the probability of C happening. So probability of B plus the probability of C. And so we had 61 that could have the favorable outcome B out of the total 200, and we're going to again add to this then the 37 of 200 for outcome C. And so doing our math, we get 0.305 plus 0.185, or we get a probability here of 0.49. Now some of you may have noticed something special here. We actually have another rule when we're doing these basic problems of probability called the complement rule. And that's why I wrote down here at the bottom for C, use the complement rule. The complement rule is useful because sometimes, honestly, it's just easier to calculate the probability of an event happening by determining the probability of it not happening. And so really when we look at the relationship here between A and B, B says find the probability that the firms make at least $1 million. And A was find the probability that they don't. So really to find the answer to B, instead of using the special rule of addition, we could have just used the complement rule, where we said that the probability of it being B or C is equal to 1 minus the probability of A occurring. And so we go back up to A, and we found the likelihood that the firm that was randomly selected would make under $1 million to be 0.51. So I take 1 minus 0.51, which again then gives me the probability of randomly selecting a firm that would be greater than a million at 0.49, which matches my answer to part B. So it's also a nice way maybe on an exam to double check your work and make sure that you're on the right track. Okay, let's move on to our second example. So in this example, I selected a problem that's going to require us to use what's called the general rule of addition. And it's a little bit different because unlike with the special rule of addition, our outcomes now are not mutually exclusive. So A can occur at the same time that B occurs. And so our formula here is a little different. To find our probabilities, we'll still calculate the probability of A happening. We'll add to that the probability of B occurring, but then I need to subtract out the probability that they both happened because we're trying to avoid double counting. Again, let's give a real example to try to make this more understanding. So we have a student, and the student is taking 2 courses. It's a summer term. He just has 2 classes. He's got a history class and a math class. So what if I tell you the probability of our student passing history is 0.6, the probability of our student passing his math class is 0.7, and the probability that he passes both history and math is 0.5. And then I'm going to ask, okay, well then find the probability that our student passes at least 1 class. So what's the probability of doing that? And again, we will use this formula right here for the general rule of addition with probabilities. So I'm going to just rewrite it for the probabilities we have. So I'm going to add the probability that he passes history to the probability of passing math, and then I'm subtracting the probability that he passed both history and math. So plugging in our values, we have 0.6 plus 0.7, and then we'll subtract from this 0.5. And when we do our calculations, then we see that the probability that our student passes at least one of his summer classes is 0.8. And that's going to be the probability there. I hope this helps you guys understand a little bit more on the rules of addition with probabilities.